Okay, identified each of the following as true or false. So number one, the set of whole numbers is a subset of real numbers. True or false? Almia. True. That's right. Okay, and I wanted to share this notation because whole numbers, we know we use W, and then we use this weird looking E right here to say it belongs to. So how we read this is the whole numbers belong to the real numbers. It's okay. What's one example? Give me a number example. A whole number that's also a real number. Yep, Melody? Three, yeah. Morning class at 1. But yes. Okay, so 1 or 3, any counting numbers, those would be correct. Okay, what about B? Who has the answer for B? Are natural numbers inside the set of integers? Crochet?
That's true.
That is true. Okay, and how we write it? N for natural number, it belongs to the set of integers. Okay, can you give me an example? Yeah. Give me any natural number.
It could be -5.
Can it be negative? If it's negative, then it's integers. But I want a natural number. So it has to be counting numbers.
5.
Right. All right. Again, the morning class at 1. So it could be 1, it could be 5, it could be 100. Yes? Oh, see? Sure. Okay. Adrena, right? Yes. Adrena, see? False. That's right. Whole numbers is not part of natural numbers. Why not? What's the one number that's not? 0, right? 0 is in this set, but not in this set. So that's why it's false. The opposite is true. Okay, D. Who has the answer for D? Kaden?
One question for D.
Okay.
Why can't the number be negative? Because like you said -5, you said negative.
Because natural numbers. Yeah, the set of natural numbers, which is the counting numbers. Yeah. So integers are in real number set, then you can have negative numbers. Okay. Do you have the answer for D?
True.
True. Rational numbers are within the real number set. Can you give me an example? Any rational numbers? 3.5, yeah. So any decimal, terminating decimal, or even a fraction. Okay, so for example, 3/8 or 3.5. Okay. E, the set of irrational numbers is also in rational numbers. I know your name. Misha? Yes. False. That's right. Can a number ever be rational and irrational? No, they're opposite of each other, so you can't. Okay. F. Prime numbers. Are they within rational numbers? Okay. By the way, what are prime numbers? Ethan.
Numbers that can only be that are only divisible by 1 and itself.
1 by n itself, right? So, do you have the answer for this one? Is it true or false?
True.
It's true, right? So prime numbers belong to the rationals. And can you give me a number example?
7.
7. That's right. All right. 2, 3, 7, 11. 5. Yes. 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 Good. You guys were paying attention. You were listening. Okay. And what about this last one right here? The set 2, 3, and pi. This is a subset of rationals. Martin? Yeah. False. Why? Why false? Pi is irrational, right? Remember, the whole family has to belong to the family. If one of them is not, then it's not. Okay, good. Number 12. Some of you were asking about number 12 right here. Yes.
The notation RQ is used to remove rational numbers from a set, leaving only irrational numbers.
Okay. Yes. So that's the standard answer in the answer key, but it sounds confusing. Okay. So just to show you guys, this line right here, this line is not a division line. It's not dividing. It's actually saying remove. Will I test you guys on these like notations? No. Okay, so this means remove. Okay. When will you guys need to know these different notations and stuff? Probably grade 11. Okay, so you'll learn different notations where like a line will mean such as or yeah and so forth. So this says all the real number, but if you remove the rational, what are you left with? Irrational. Okay.
My math teacher helped me with the question.
Oh, okay. Good. Okay. Yeah, because like you can think of it as like the real number, take away the irrational numbers, it will leave you with just the rational, basically. This is, yeah. No, because like you see remember in that diagram that we have, this is the real number set, and then these are the rational numbers, and then this is the irrational number circle. So if you take away this circle, what's left is this. Okay, and then number 13, describe a real life situation where numbers, the natural numbers is not enough, but the whole numbers are. So the example and the answer that they said is when you throw a ball, you need to start from times 0. Okay?
What about temperature?
Temperature actually goes into the negatives. So in this example here, they're just saying, why is it not enough to just start at 1? And so in real life situation, time starts at 0. We can't teleport. So and we have no time machine. So that's one example of why 0 is important. Okay, so hopefully that answered some of your questions. Okay, today. Okay, I want to go over page 10. Okay, page 10. Yeah, so page 10, I actually I gave it a title: density and limits. Page 10.
Density primitive size.
Yeah, but the government decided to change the math curriculum.
Was it density plus math now?
Yeah, I know. So is coding. Coding, instead of teaching it to you guys in computer science class, is also in math as well. They just throw everything in math.
Just like
Exactly. See how important math is and how your teacher have to teach everything. You know? Yes. Okay, so let's okay, so density. So let's go over example 7a. So how do you determine density? Density, I'll do it in an example because it makes more sense. So how do you determine the density level is the more elements in the set, the more density. Okay. So in the first one, we're comparing how many numbers are between 0 and 30. How many whole numbers? Yep.
0.1.
No, how many whole numbers? Just whole numbers. Remember, whole numbers are like the counting numbers and including 0. So how many whole numbers are between 0 to 30?
Does 30 count as one?
Yep.
Oh,
Yep.
31.
31, right. So there's 31 numbers in this set. 0, 1, 2, 3, 4, 5, 6, all the way up to 29 and 30. So if you count correctly, there's 31 numbers in this set. Right? What about the rational numbers between 0 and 30? Yeah, Melody? Infinite, because you can have decimals, you can have fractions. So this set actually has infinite number of elements. So which one has more? Obviously this one. And so we say this is more dense. It has higher density. Okay? That's all it means, density. So less confused and science type.
Science isn't like math divided.
Right. Okay, but because of the vocabulary, they decide to use the same word for different meanings. Tomato, tomato, you know. Yes. So, and then density property. So if you Google density property, it will give you a definition in another language. It doesn't make sense. Okay. So the way that how I would explain density property is if you can have a number between two number sets. No, two numbers. Yeah, just two numbers. So like if you can have another number between two numbers. Right? So for example, right here, natural numbers. Right? Between 1 and 2, is there another natural number between 1 and 2? No. So that means it does not have the density property. Right? That's all it means.
What? Can you explain that?
Sure. All right. So density property means like if you can have a number between two numbers in the set. So for example, right here, natural numbers, it's like 1 and 2 or 5 and 6, like the counting numbers, right? Can you have another number between two counting numbers? No. So like between 5 and 6? Right, you can't because otherwise it's not another natural.
So if there isn't any numbers like between two numbers, then you can density.
Say that again.
So if there isn't like a numbers between each numbers, then it doesn't have a density level.
Then it doesn't have the density property, just the property. Yeah.
And then the numbers
So for example here, integers. Okay, so what about integers? Give me two consecutive integers. -6 and -7. So between -6 and -7, can there be another negative integer? No. Nope. There isn't another negative integer between those two. So that's why it's no. I'll do an example where you can. Okay.
Can't you have like -6.5?
Then that's not integer.
Oh.
Right. Okay. What about irrational numbers? Okay, give me one irrational number.
4.5 and
4.5 is a rational because it's a term and it is. So what's the famous irrational number? Pi, right. So between pi and square root
of 2.
Square root of 2 is 1.4 something, so it's less than that. 89. There. Okay, between pi and square root of 89, is there another irrational number between them? There's tons. So then, yes, it has the density property. Does that make sense? I think the best way to explain an definition is through examples. Okay. Okay. One last thing I want to go over. Limits. Okay. Number 11 right here, limits. What is a limit? Limit is when the list of numbers get closer and closer and closer to a certain number. So for example, A right here, 7.1, 7.01, 7.0001, and so forth. What number is it get approaching? 7. That's right. So your limit is 7. Yeah. They couldn't just ask you what number is it approaching. They couldn't call it approach. They have to call it limit. When do you learn limit? In calculus, grade 12.
We have to.
You don't have to.
But you don't have to.
But if the university requires you to, then yes. That's why people take it, because
Grade 12, there's like 3.
Yeah.
There's like 5 for sure. Is it algebra? That's part of it.
yes.
What's the other?
Let me finish this one last example first. Okay, this one is a little trickier. Okay, negative 2.6, negative 2.66, negative 2.666, negative 2.66. What number is it getting closer and closer and closer to?
Negative 2.7.
Yeah, you could. All right, you could say that it is getting closer to that, but there's a closer. There is a closer limit. This one is a tricky one. So this one, it's approaching negative 2.6 infinite. Repeated. Okay, so when you have that line on top, it means it's repeating. So like all the number is approaching negative 2.6 repeatedly. Okay. So right now, I want you guys to do some partner work or group work. All right. Work with a partner on page 10 and 11. Right? I want you guys to discuss about limits and density. And I know that sometimes it could get confusing. That's why I want you to work with someone. I'll say partner or group of 3 because I know some of you are like friends with a lot of people. Okay. So let's say about 10 to 15 minutes, and then we'll come back together to work on page 13. Okay, so I just want to take up number 12 really quickly. I love how you guys work together. I heard a lot of great ideas, collaboration. You weren't only asking me, you were asking your friends, and then you guys were helping each other. I love seeing that, okay? So, and remember, there's only one of me to 25 of you guys. So sometimes if I can't get to you right away, you can always ask your friend, and then they can, after they answer your question, maybe you'll see the math differently, and you'll understand it. Okay. So number 12 right here, I just want to really quickly take this up. Fractions, decimals, which do you think is easier? To you, which is easier, fractions or decimals? Decimals, yes. I think so too. So when I see fractions, what I like to do is I like to divide it out. So 1 divided by 2 is just 0.5, 1 divided by 4 is 0.25, and so forth. So when I rewrite it out, I can see it easier. It's easier to see. So describe the sequence that is constructed. So every time what's happening, I'm dividing it by 2. Yeah, by 2. Okay. Does this set have the density property? No, because I'm dividing by 2 in between. So between 1 and 0.5, I already divided by 2. So there isn't another number in between. So no. And then what is the limit here? So looking at this pattern right here, what number is it approaching? Yep, Ethan? 0. So 0 is my limit. Okay. Will it ever go to 0? No, right? That's what limits are. Limit is it approaches this, but it doesn't have to hit it. Right? Yep, so that was what you guys just worked on. Let's move on to page 13. Okay, so let's say number 2, page 13, number 2. You're going into pizza. Okay, one pizza is cut into 5 slices. The other pizza is cut into 4 slices. Which one do you want to buy? 1/4. That's right. All right. You can see, like when you go into pizza place, you want the bigger slice. I always look at their display and then I'm like, that one looks good. Okay, so that's how I just determine if I want the pepperoni pizza or the cheese pizza. I look at which slice is bigger. Actually. Okay, so this one is nice and easy to see because it's just 1/5 and 1/4. All right, as we said, we like decimals more because it's nice and easy to see. So 1/5 is just simply 1 divided by 5, and I get 0.2. All right. And then what about 1/4? 1 divided by 4 is 0.25. Okay. And so in comparison, I can see that, well, 0.2 is less than 0.25. Right? So if let's say this question is in the multiple choice, the easiest way to do it is change it to a decimal. All right? Because remember, multiple choice. Do you have to show any work for multiple choice? No, you can even guess it if you want. So in multiple choice question, in questions on the test that's worth 1 mark only, you can do whatever method that works for you. You can draw a diagram, you can change it to a decimal. It's just 1 mark, right or wrong. Okay. But let's say you have to do show some work. So for example, equivalent fraction. So I need to change a half to another fraction that has a denominator of 6. Okay, so to change the denominator, 2 times what gives me 6? 3. Yeah, I have to times it by 3. So whatever I do to the top, I have to do to the bottom, and vice versa. So 1 times the 3 gives me the 3. Right? So a half is just the same as 3/6. Okay, we all know that from grade 6, I think. Okay. Now jumping to here, 6f. 6f, 1/7 of 224. Okay. Anyone know how to calculate this? 1/7 of 224. Melody? Good. Okay, so the simplest way to do this question is just do 224 divided by 7. But I can only do that because this is 1/7. If it's 5/7, if it's 6/7, I can't. It will give me a different answer. So how you can, the method that you should do that will work every time is change this to divide this out first. So 1 divided by 7, because 1/7 is just 1 divided by 7. Of means times. The word of means times. Keep that in mind. We will get back to more of these later when we do like pricing and sales and stuff. And then 224. Right? So on your calculator, you would do 1 divided by 7. You get this decimal, times it by 224, and you'll get the answer 32. Okay? So 1/7 of that is just 1 divided by 7. times the number. Okay? Okay, page 15. Page 15. Okay, so this would be an example of a question that is not in a multiple choice, maybe worth 2 marks. So if it's worth 2 marks, do you think it's enough just to show if it's less than or greater than? No, answers mean nothing to me without the steps. Okay, so you need to show some steps. So let's say this question is worth 2 marks. You need to show me 2 steps. So 10 over 3 and 13 over 4. I don't know which one is bigger, which one is smaller. Why is it hard to tell? Yeah. Because the denominator is different. So this pizza is cut into 3s, this pizza is cut into 4s. So what's the common denominator between them? Yep, 12. That's right. So I can take my pizza and cut them all into 12 slices. How do I go from 3 to 12? Times 4. That's right. So whatever I do to the top, I'd have to do to the bottom and vice versa. So 3 times 4 gives me 12. 10 times 4 gives me 40. Same thing here. 4 times 3 gives me 12. So 13 times 3 gives me 39. Right? That's why equivalent ratio is important. Now that they're both pizza are cut into 12 slices, I can tell that this one has more slice. There's 40 slice instead of 39. So I want that deal. Okay. One last example right here. Number 14. I get this question a lot. Right? I see a negative 4 over 5. I have a negative on the side. Is this the same as putting the negative to the top? Who says yes? Who says no? And it is yes. As long as there's one negative in the fraction, it doesn't matter where that negative is. Okay, so negative 4 over 5 is the same as negative 4 over 5. What about negative 4 divided by negative 5? Who says it's yes, it's the same? Who says no, it's not the same? Wow, I only have 5 people in class? Let me ask that again. Is this the same? Who says yes? Who says no? Yay, I have more people in class now. Because 2 negative is a positive, so it's not the same. What about this one? Let's say if you guys are awake. Negative 4 over 5, is that the same as positive 4 over 5? Who says yes? Okay. Who says no? Yay, my whole class is correct. You passed kindergarten. And then what about this one? Here's the grade 9 question. 4 over negative 5. Who says yes, it's the same? Good. Why? Sarah?
Because it's a negative, like there's a negative in the fraction.
Right. So no matter where that negative is, as long as there's one negative, the whole fraction is negative. All right. I get this question all the time. And now you know. Okay. So your homework for tonight. You still have 10 minutes to get as much done as you can. And then it's up to page 15. Okay. I'm thinking to do a homework check tomorrow. Okay, so a quick homework check tomorrow. I'm just going to walk around the class, making sure that you guys are up, have good work habit and doing your daily homework. Okay, so I'm going to check up to page 15.